Okay, and just check the deviation. It's a vertical well, so you have the measured depth against the TVD, the true vertical depth. You can see the plot here, cumulative displacement versus true vertical depth. And the equipment, so this is the existing condition, starting point from here down to this, the end of the tubing. And my tubing has dimension of this, external diameter of 2.875, internal diameter of 2.441, just a template absolute roughness. You can change this value if you have a certain number of it. And casing as well, down to the total depth of the well and external diameter of 5.5 inches, internal diameter 5 inches, absolute roughness of this one. Okay, and temperature model, let's see. So temperature model calculated using the surface surrounding temperature 83 degrees Fahrenheit. Okay, very easy. And you just input this surface surrounding temperature. And ESP data, it's very important. So currently I equip my well with DN 2400 Reda pump with this range of flow rates. Minimum flow rate is 1500, 1500 stock tank barrel per day with maximum flow rate 3200 stock tank barrel per day. I have to 125 stages with the pump is quite old, so the pump wear factor is 0.5. So I have my pump curve here. And the other data, the motor model, the motor that I use, 460 56 PK series, nameplate rating you can see, operating rating 100 horsepower, 55 ampere and 1150 volts. And this is the location of the pump setting depth, maximum equivalent outer diameter 5 inches. It cannot be bigger than the internal diameter of the casing. Operating frequency 60 Hertz. Okay, it's already in optimum condition. Upstream temperature 120 degrees Fahrenheit. Okay, so let's see reservoir before we go. So currently I have my well test data to describe the performance of my reservoir. My reservoir is called T reservoir. It's a sandstone reservoir and reservoir pressure 921.7 psia with temperature 180. Middle perforation at this step, water cut is already very high, okay, 99%, but you can still produce oil, you can still get oil from it. But of course, we need opportunity to increase the flow rate, the oil rate. So that's why we want to open another reservoir. Gas oil ratio 300. And I want to construct my IPR using Vogel equation. Okay, and I have my well test data. So I input the well test data to obtain the IPR. So I input my test pressure. In this case, the pump intake pressure. I have the data taken from the downhole gauge. Okay, so the value is 791.7 T PSIA, and I also conduct well testing to measure the flow rate, and I get 1028. So using simple calculation, you automatically get calculated bottom hole pressure of 847.31 PSI. Okay, so you get the productivity index J of 14 stock tank barrel per day per PSI with absolute open flow AOF of 7,231 stock tank barrel per day. So you can also construct the IPR. So the IPR is like this, and your current operating condition is around here. Relative permeability, you can actually skip it. Okay. Many times you can just leave it like this. Okay. Because to construct the IPR, it's actually not very, yeah, don't need to be very detailed, okay, such that you go into very detail with relative permeability. But if you want to input the representative number for the relative permeability, of course you can. Okay. All right, and let's go to analysis.